What is up, everybody, and welcome to Iron Vlog number 205. Holy fuck, I've been doing this a long time. This is my journey to become Iron Man. This is my Iron Man suit. This is it, guys. This is the money right here. Really fucking cool. Very, very happy with it, the way it's going right now. This is it with me inside the suit. So this purple thing is a 3D scan I had made. Did not use photogrammetry for that scan. Different type of scan. Bounced light off of me and then caught the light and turned it into a scan of me. Pretty fucking cool. Paid to have that done. Anyway, then what I did is I went through and I put in a sketch into here that had all the joints in my body, figured those out. I've studied anatomy, kind of figured that out, and then I'm building all these joints around the center of all my joints. All these exoskeleton joints around the center of my human joints is what I was trying to say. Today what I'm showing you guys is the thigh. The thigh is looking real good. It's looking real good. So here's the main file of it right here. So as you can see right here, this is where it attaches into the pelvis. Up here, this and this and this are all points for exomuscle anchors, which are the high strength actuators that I built. They're the highest strength to weight ratio hydraulic actuators ever made, actually. But they're flexible and they will be running through the inside of the suit in theory. At least it's going to have anchor points for them if we want to put them in there. And then there's this double system joint right here, and they add together to give it 180 degrees. And here you can see it maybe move. Yep, there we go. So there you go, you get 180 degrees. And then what you get with this is you get two layers, and they both add up to 180, and then you get two layers this way and two layers this way. And this is a deep and superficial exoskeleton, so this cavity in here allows for these exomuscles to be supported on both sides, as you can see. And that's really key to having these things work, because they have such a high strength to weight ratio. They would like literally shear apart titanium if they were just on the outside of a solid piece of like type 5 titanium, which is a very high strength alloy of titanium, stronger than a lot of stainless steels. It would still shear it. I mean, it would just completely bend it like it was nothing with 5 tons of force. So very important that this is supported on both sides, kind of like being like the force being confined to like the inside of a pipe versus like on the outside of a bar. The outside of a bar obviously is going to be a lot easier to bend than the inside of a pipe. Let's take a look here, guys. This will be pretty cool. So this right here is going to show you the motion of how this thing works, which is pretty neat. So it's going back and forth like it just did, and then now it's going to do that internal and external rotation right there. So it's internally and externally rotating, and now it's going to go backwards. It's going to go forwards like that. It's going to come back down, and then it's going to come up and down like you were doing the splits or stepping like inside your foot or something like that, walking like a ninja, something like that. So so that's the motion of this suit, which is pretty fucking cool. So there's, let's see, 1, 2, 3 axes of rotation for this. A little bit simpler than the shoulder up here. The shoulder is 5 axes of rotation, but it's very similar in design. Because there's, like with the arm, your arm is very close to the body here. So this is a lot more complicated, and therefore it's not quite as strong. This, because it's like wrapping around the leg, because your legs point straight down, you have more like ability to kind of wrap around them. You can make the suit stronger and bulkier, which is pretty cool, and kind of what you want in the lower body, where you're going to have higher forces on the suit, right? So just the weight of the suit, and then generally you get more higher force loads over your lower body. Now the musculature is really similar. I'm using like the same type of exomuscles on both sides, but they may be powered a little bit differently. Like I might can probably maybe bump up the power a little bit in the lower body than I can on the upper body, because there's more bulk in the suit. So so that's all cool, and this is pretty fucking cool. Yeah. So what I need to do now, I said finished. It's not 100% finished. So I was thinking about it. At first I was just going to put these, and these are really similar both for this here, the thigh, and this here, the arm. There it is with me inside it. So these two are really similar in design, like very similar. You can see these two are a lot more on top of each other. That's because this, like I said, has to move around the torso, so it has to be a little bit less bulk on it. The nice thing about the arm is I can put this piece on the back, which will strengthen it up quite a bit. But these just two had to be kind of more on top of each other. Anyway, at first what I was going to do is I wasn't going to have an inside elbow joint. So I have these two on the deep and superficial. On one of my old designs, I also had just a single one on the inside to give it a little bit of extra oomph. But I also had a single one of these sliding joints on the inside. So I decided to take that out, but I think now what I'm going to do is I'm going to pull off from the outer piece and have it kind of bolt in, kind of like this piece bolts on. So this entire piece comes in and bolts on. I think I'm going to have another part that comes in and bolts on to this piece right here. So the part that's blue, I think I'm going to have a piece that comes and bolts on here, and then it'll be able to like slide up against this. So it would work in compression. It just wouldn't work in tension very well. So if you're picking something up, it wouldn't really add any strength at all. But if you're doing push-ups or something, or I don't know, holding something really heavy above your head, it would work in compression. So I'm thinking about maybe doing that and then having a single one of these on the inside. And the reason for that is if we go over here and we look at the arm, this is from draft, I can't remember, 3 or 4. I think it's from draft 4. Yeah, this is a draft 4 version. So if you see here, you see how like these two parts would marry and touch. So if I get the joint moving here, you'll see how like they come back. Maybe, yep, there we go. Oops. You see how it comes back and it marries right there, and it's really there's a part that's not turned on for some reason. Bam, there we go. So you see how these marry really well. I want to do something like that on the version I'm working on now. That's pretty important, that you can't overextend your elbows and your knees. So something like this I need on the outside, and I think it would just be nice to have another piece right here on the inside. So having something like this on the back side that'll keep that joint from overextending, essentially hyperextending. I want something like that on there, and it would just be nice to have something on the inside of the arm to kind of support that. So as you can see here, this is an old design, but there's 1, 2 layers here and then one on this side, and then my arm would run to the middle of it like that. So I think I'm going to do something like that. I think I'm going to do something like that. If not, I still need to get that back part on where they lock together. So I still have to do that on both this arm right here. So this arm needs to have a piece that comes down, and then the forearm will be on the other side of that, and they'll lock together. And then on this thigh piece as well, there needs to be a piece going like around to the front of the knee, and then maybe like one of those small joints right here on the inside of the knee, and then have it to where you can't hyperextend your knee. I think that would be very smart to have on an Iron Man suit. Keep some bad guy from breaking my knee. And it just keeps the suit from accidentally trying to bend out the other way, which is actually more important when you like walk or something. If it kind of like got leveraged back, it could like pop backwards and then like kind of hurt your knee. So it's really good to have that not hyperextend. So and it's just a better design too. So anyway, I need to do something where this is going to be kind of flattened out, and then there's going to be a strut that runs around, and then I might end up putting another joint here on the inside. But the reason I'm calling this good on this part of the suit is that stuff is mostly going to be associated with like how it kind of matches up with the next part of the suit, which is going to be the shank here and the forearm here. And then after that, to finish, all I have to do is the foot and the hand. So as you can see, guys, this shit's really coming together. The next thing that I'm going to work on, like I said, is the forearm and the shank, and I really got to get those figured out. But what'll end up happening is won't seem like I'm doing a whole lot of work on the actual shank and the forearm, because I'm going to be working on like the intersection between those two parts and the arm and the thigh. So I have to work on like the intersection between those, and then once I get that figured out, then I'll kind of run down probably the forearm and the shank pretty quickly, and then it'll just be up to the phalanges, just the stuff on the end, which is going to be really fucking cool, because I'm going to be fucking done with it. And then fucking save some money up, buy the shit and build it, fucking weld it together. It's going to be made out of aluminum. If you're new to the channel, you don't know what the fuck how this thing's going together. It's going to be water jet cut aluminum that's going to be tabbed. It's going to tab together, and then I'm going to weld it together. And then to cover the gaps in the armor, the ones that are designed in there anyway, there's going to be gaps that aren't covered, but the ones there's in between a lot of the struts where there's like a lot of gaps and looks really spindly, is going to be a thin sheet of metal of aluminum that's going to be hammer forged out, and then welded into those spots. And what I'm probably going to do is I'm also going to build at least I'm going to build a couple of tools to help me build this thing when I get it water jet cut. One of those tools is going to be like a set of rollers, but like most rollers you think of been like pipe, and they're really bulky, and they in order to handle a high load on the pipe, but they're really small and narrow. These ones are going to be longer, and they're not going to be quite as bulky because they won't be carrying quite as much load because they'll be bending thin gauge metal. But there'll be a set of like 3 rings, and then you adjust the middle one, and that adjusts the radius of your sheet, of the bend you want to put into your sheet. So I'm going to build one of those, and I'll put a wheel on it, and I'll be able to wheel it through and get really nice smooth curves on the parts for the sheet metal that have nice smooth curves. Some of them won't. Some of them will be compounding curves, and I'll do those ones by hand with a rubber mallet and a piece of steel as like an anvil. But then, so once I get it all welded together, then I'll make those sheets, and those sheets will go on there and weld on, and those will give a lot more strength to the thing too. I can make it way more rigid. So it's pretty cool, guys. Smash the subscribe button if you're new. I love you. Have a good one.